This video is concerning mixing concentrations using a technique called the alligation technique. Our question: you have two stock solutions, solution A, which is 80 milligrams in 5 mils, and solution B, which is 200 milligrams in 5 mils. You are asked to make 200 mils of a solution which is 120 milligrams in 5 mils. How much solution A and solution B do you need to use? So this sort of question can look quite daunting on face value, but I promise you, if you can remember how to fill in a grid and to apply one equation, then it's honestly not as bad as it might first look. So the grid that we need to use is a simple 3x3 grid. So you draw that a bit like a noughts and crosses grid, with or without a border, whichever you prefer. And then you need to remember that there are three figures that need to get filled into this grid. And they get filled into the top left corner, the bottom left, and the middle. So the figure that goes into the top left corner is the highest strength solution that you're starting out with, which in this case is solution B. In the bottom left hand corner is the strength of your lowest strength solution, which in this case is solution A, and in the middle is our final concentration. Luckily in this question all of our strengths are expressed in the same format, which are a strength per 5 mils. Do watch out in the exam for questions where perhaps the format might be different. So some strengths might be expressed per 5 mils, some per 10 mil or per mil, or maybe a percentage. You need to convert everything to the same format before you start. But luckily this example, everything's in the same format. So we can simply plug them in. So we know our highest strength solution, solution B, is 200 milligrams per 5 mils. So we fill in 200 in the top left hand corner. We know that our low strength solution is solution A at 80 milligrams per 5 mils. So we fill in 80 in the lowest corner. So high strength in the highest left corner, lowest strength in the lowest left corner. And in the middle we get our final strength, which is 120. Okay, so you always start by filling in those three values. The next thing you need to do is to subtract across the diagonals. So we take the difference between the bottom left and the middle, and we fill that value in the top right corner. So the difference between 120 and 80 is 40. Now this 40 relates across the horizontal to our 200 milligram strength solution, and it tells us that we need 40 parts of that solution. So we need 40 parts of solution B. Get a different coloured pen just for clarity. We then need to subtract across the other diagonal the difference between our highest strength solution and our final strength. 200 minus 120 is a difference of 80. And that relates again across the horizontal to our 80 milligram strength solution, and that tells us that we need 80 parts of the 80 milligram per 5 ml solution, which is solution A. Bear with us, because as soon as we start doing the equation, hopefully this will become more clear for you. I would then note that knowing now that we need 40 parts of solution B and 80 parts of solution A, if we add these together, we need 120 parts in total. This becomes relevant for our equation. So for each solution, the volume needed is equal to the final volume multiplied by the number of parts needed of that solution divided by the total number of parts. That is the equation that you need to know. Okay. So if we apply that to each solution, so the volume of solution A needed is equal to the final volume, which we're given in the question. The final volume is 200, multiplied by the number of parts we need of solution A, which is what we calculated from the grid. And we know we need 80 parts of solution A. We then divide that by the total number of parts, which is 40 parts plus 80 is 120, which equals 16,000 divided by 120, which equals 133.33 mils. That's our volume that we need of solution A. We then perform the same equation for solution B. Volume of solution B equals the final volume, again from the question, 200 mils, multiplied the number of parts of solution B, which is 40, divided by the total number of parts, 120, equals 8,000 divided by 120, and that comes out at 66.67 mils is what we need of solution B. Now you can apply a final check on these figures. We know that our final volume is 200 mils. We have 133.33 mils of solution A. We have 66.7 mils of solution B. Those two added together equals 200 mils. That's a good final check that our answers are probably right. I know this is a little bit complicated, but honestly, it's the easiest way that I've found of tackling this sort of question. If any of you know an easier way, feel free to pass it on to me and we'll share it. But this works for me and I hope it works for you too.